We've previously talked about recursion specifically in Python, but in more general terms as well. Now we want to take a look at some examples of recursion in practice. One is to find the total of a list, and I have here a function called total. And I say if my start index is less than the length of my list, then I'm going to return my list at the index plus, and then I'm going to call total again. I'm passing in my list and incrementing the starting point. So that's just real quickly how this is going to work. Inside my main function, I have a list called the list I'm going to pass in, and it's just some initial values. When I call this file, you'll notice it just says the total is and gives me a total. While this example is simple and easily done with a loop, is a simple way of showing how it can be done with recursion. A couple of minor changes: I can give a default value for start, and then I don't have to specify it down here, and this would work the exact same way. Just makes it a little bit easier to work with, but it's not that complicated. You are more commonly going to see recursion with special mathematical functions. For example, this factorial. A factorial is a number times itself times minus 1 times itself minus 2 times itself minus 3, etc., all the way down to 1. So we specify as long as if num is less than 0, we're going to return 0. If it's equal to 0, we're going to return 1. If it's any other number, it's the number times factorial minus 1 from that number. This way, if we said factorial -3, we get 0, which is the legitimate value. Otherwise, it's going to be counting down for us. So that's that conditional check that we always put in. When I run this example, you'll notice I get some different values based upon what random numbers were picked for me. Notice I have some that are pretty small. For example, 1 factorial is 1. On the other hand, I have some that go up much higher. You can see all those different values. Factorial numbers tend to grow very large very quickly. And so inside of my test, I made sure that those numbers didn't get too big. Another example of recursion can be found in the Fibonacci sequence. A Fibonacci sequence is the previous two numbers added together. If there is no number, 0 is used. If there's a second number, it's only 1, and then it goes from there. So usually we count from 1 on up. Well, with Fibonacci, it's helpful to actually start at our ending point and go backwards. And so here we have this information. And when we run this, we can see different Fibonacci sequences based upon what the initial number is and then getting a value. So it lets us know very quickly where these are. These numbers also grow pretty rapidly, but not nearly as fast as a recursive function. But is a perfect example of something that we can use using a recursive call because of its very nature of growing based upon itself. Certain mathematical functions are naturally built and designed for recursion. Everything from fractals to factorials to Fibonacci sequences, as we've seen here, are perfect examples of where recursion is easily used inside of Python and other languages.